Okay, so today we're looking at something that usually just sits in a tangled mess behind your TV, gathering dust.
Right. The thing we all try to ignore.
Exactly. It's a cable, specifically the NTI HD4K18GB-FO-15M-MM. And before you skip ahead thinking it's just a cord,
It's really not.
it's not. It represents a solution to a massive physics problem. I mean, how do you move a 4K video signal 50 feet across a room without it turning into digital garbage?
It sounds boring until you realize that copper wire, the stuff we've used for, what, a century? It's hitting a physical wall.
So this NTI cable is something different.
It's a fascinating case study. It's trying to bridge that gap between the electrical age and, well, the optical age.
I have to admit, when I saw hybrid optical cable on spec sheet, my alarm bells went off. Hybrid can be a red flag.
Usually in tech marketing, that just means we couldn't decide on a standard or is just a gimmick to hike the price. But here you're saying the mix of materials actually serves a real function. Oh, absolutely. It's an engineering compromise, but a really smart one. Inside this cable, you have 4 fiber optic cores doing all the heavy lifting.
The actual video transmission.
The video, yeah. But running right alongside those glass fibers are 7 copper conductors.
But wait, hold on. If fiber is so much superior for data speed,
Huh?
why keep the copper at all? Why not just go 100% optical?
Because the HDMI standard itself, it wasn't originally built for light. It was built for electricity. Still need that copper to handle the boring stuff, like the handshake.
That's the term for how the devices talk to each other, right?
Ideally, yes, it's how your TV and your Blu-ray player agree on what resolution to show. If that electrical signal doesn't get through, you just get a black screen.
Nothing.
So this NTI cable uses the fiber cores to shoot light for the video, which gives you 0 signal loss over that 15-meter distance, while the copper handles all those electrical negotiations.
Let's dig into that zero signal loss part. The sources mention this cable is designed for environments like medical imaging rooms or even airplane onboard systems. Why is fiber safer there?
Well, it comes down to some pretty basic particle physics.
Okay.
Your standard copper cables transmit electrons. Electrons have a charge, which means they can be pushed around by magnetic fields.
Right, interference.
Exactly. If you run a copper cable next to an MRI machine, the electromagnetic interference just wrecks the flow of electrons. That noise destroys the image.
And fiber.
Fiber transmits photons. Photons have no charge. They are physically incapable of picking up magnetic interference. You could run this cable through a magnetic storm, and the data would arrive perfectly intact.
That makes sense. That explains why a surgeon would want this. You can't have the monitor flickering just because some other machine turned on.
Absolutely not.
Now, looking at the specs here, it says this supports 4K at 60 Hz with 4.4.4 color depth. I see that number a lot, but what does it actually mean for someone watching?
It all comes down to color compression. Most video you stream, let's say online, compresses color information to save bandwidth. That's called 4.2.0.
Got it.
But 4.4.4 means 0 color compression. It is the raw, full signal, pixel for pixel. This cable pushes 18 gigabits per second to make sure every single bit of colored data leaving the source actually hits the display.
That is a staggering amount of data. And for the audio files, it also handles Dolby True HD and DTS HD master audio, so the sound is just as pure as the picture. Here's the other thing that confused me. It's an active cable. Usually that means I have to find another wall outlet to plug in a power brick, but I don't see a power cable here.
And this is my favorite part of the design. It's like a parasite, but in a good way.
Oh, good parasite.
It sips just enough electricity, specifically the plus 5V, directly from pin 18 of the HDMI port on your PlayStation or your cable box.
No way. So it powers its own internal lasers using the juice from the HDMI port.
As long as your source delivers 500 mA, which most do these days, it powers the entire fiber optic engine without you ever needing an external adapter. It keeps the whole setup incredibly clean.
Speaking of clean, the physical build surprised me. For all this tech, I expected a fire hose, but this thing is only 4.5 millimeters thick. It has a tight bend radius, too.
48 millimeters.
Yeah.
And that flexibility is crucial because of who's buying this. If you are installing digital signage or routing a cable through a conduit in a wall, you just can't work with a stiff, heavy cable.
That brings us to the elephant in the room.
The price.
The price. We're looking at $186 for the 15-meter version. I mean, that is a steep jump from the $10 bin at the electronics store.
It is. But context is everything here. In a home theater, maybe you're paying for future-proofing. But in a professional setting, digital signage, a broadcast booth, or that medical suite we talked about, the cost of failure is much, much higher than $186.
So you're not just buying a cable.
No, you are paying for the guarantee that the signal at meter 15 is mathematically identical to the signal at meter 0.
So for you listening, if you're just hooking up a DVD player 3 feet away, this is definitely overkill. But if you're running a projector across a large room and you need absolute perfect fidelity, this is the solution.
We're using light to defeat the limitations of electrical resistance. It's really the only way to move that much data instantly over that kind of distance.
Which really just highlights the shift we're seeing. We've gone from simple copper cords to these hybrid fiber optic engines.
And it leaves us with a provocative thought. If fiber optics are now becoming necessary just to move a video signal across a living room without loss, are we finally approaching the absolute physical limit of copper in our daily lives?
Something to think about the next time you plug in your TV. Thanks for listening.